All right, so here's our last video on working with logarithmic expressions and functions. So before we get into the little bit of notes for today, I wanted to kind of tie back to what we did the very first day of this unit, where we learned about the properties of exponents. Well, I guess where we refreshed our rules of properties for exponents. So I want you to focus on these two middle terms right here and see how they relate. So if you recall, when we talked about multiplying terms with the same base, so whether it's a 3, whether it's an x, if we had x to the first times x squared times x to the third, we would add those powers. So that would become x to the sixth equals x to the sixth. So here you can see I have 3 to the first times 3 to the first times 3 to the first, which is the same thing as 3 to the 1 plus 1 plus 1. Now, if we break out from these two terms, 3 to the first times 3 to the first times 3 to the first is 27. But if we take this term and go backwards this way, 3 to the 1 plus 1 plus 1 is 3 to the third, which is the same thing as 27, obviously. So we know it kind of helps me to see that these two they work, no matter which way you think about it. 3 to the 1 plus 1 plus 1 is 3 to the third. But 3 to the 1 times 3 to the 1 times 3 to the 1 is all equal to 27. 3 times 3 times 3 is 27. So this addition of exponents is a really key idea. We're not adding the threes, we're adding the powers when we're multiplying terms together. And something very similar happens in the new log rule we're going to learn today. So log base 3 of 27 equals 3. So if we think back, we know 3 to the third power equals 27. So 3 to the third power equals 27. So that's a true statement. As we kind of discussed above, I can rewrite 27 as 3 to the first times 3 to the first times 3 to the first. So how can we look at this in terms of log? So I'm going to write that over here. Log base 3 of 3 times 3 times 3. So let's do what I did above. Let's turn this into an exponent. So log base 3 of 27 is the same thing as log base 3 of 3 to the first times 3 to the first times 3 to the first, which is the same thing as log base 3 of 3 to the third power. So remembering our power rule from last class, this 3, we remember can come out front. So this becomes 3 log base 3 of 3. So 3 log base 3 of 3. So what I have here, I've turned this term here into 3. So I guess this term here into 3 log base 3 of 3s. And when I have 3 of anything, if I just have 3 x's, for example, this would just be the same thing as writing x plus x plus x. So 3 log base 3 of 3s, I can write as log base 3 of 3 plus another log base 3 of 3 plus another log base 3 of 3. So all I'm doing, I'm just rewriting these expressions in different forms, but that they mean the same thing. So you can see log base 3 of 27 is the same as log base 3 of 3 times 3 times 3. 3 times 3 times 3 can be written as 3 to the third. And using the power rule we learned from last class, log base 3 of 3 to the third can be written as 3 log base 3 of 3. 3 log base 3 of 3, I can break out and turn into these 3 terms connected through addition. And we know, to bring this all together, log base 3 of 3, this is saying 3 to what power equals 3? This just equals 1. So this becomes 1 plus 1 plus 1 equals 3. So here again, you can see a really neat example of how multiplication is very, 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 very connected to addition of the terms when you're talking about logs and exponents. So that's kind of the background of one of the rules we're going to learn today. So I always want to give you a little bit of information about why these rules work and not just kind of spoon feed you and hand you the rules. So On your note packet, in your note packet, we're going to start with our three new properties of log functions. All right. And the same rules apply for natural log functions, right? We talked about those are, highly related. They're the same thing, basically, just written differently. So what we just looked at, if I have two terms that are being multiplied within the log, they can be expanded by turning them into addition. So log base 3 of 3 times 3 times 3, I can expand and write it as log base 3 of 3 plus log base 3 of 3 plus log base 3 of 3. So this first property, log of x times y, can be written as log of x plus log y. So log base 10 of x plus log base 10 of y. Log base 2xz, since it's connected through multiplication within the log term, we can expand it. We can break it out into three separate terms and connect them through addition. Log 2 plus log x plus log z. Okay, and again, just like with exponents, division of terms, division of powers, so like x to the fourth over x squared. For this, we don't multiply the terms, we subtract them. So this becomes x squared. I guess what it really is x to the fourth. Well, you know what, let me take that back. We know it's just x squared. It would become basically x to the 4 minus 2, which is x squared. But the same thing happens for log terms. When we're dividing terms within a log expression or a log function, we can break them apart, we can expand them and connect them through subtracting. So given that log of 8 over 5 equals log 8 minus log 5, therefore log of x over y equals log x minus log y. All right, and careful here. I think you've looked at this in past years, but be really thoughtful. Anything in the numerator now. So basically, I guess this x, since it's in the numerator, is a positive overall term. We just didn't really write it because we're just thinking about subtracting. But the next example we have to be careful with, we have log 3 plus log x. Those are both terms that are in the numerator. Okay, those are both terms that are in the numerator. So they both have like an overall positive sign. They're connected through addition. And then I like to do this a certain way. I know some teachers have taught it a different way for you guys. The y and the z terms are both in the denominator, so we're subtracting those terms. So here's what some teachers do, which is fine, which is totally fine. We're subtracting this quantity, this entire denominator. So it's minus log y plus log z. The way I was always taught and the way that it kind of makes sense in my mind more, I just think about subtracting each term individually. So really just distributing that negative sign through. I just think about this in my head as log 3 plus log x minus log y minus log z. But either one of those are equivalent. All right, so I hope that makes sense. So that's our product rule and our quotient rule. We'll define those in the next page. This we talked about last time, but here's our power rule. This is the one I basically showed you on the last page. Log of 2 to the third power is the same thing as log 2 times log 2. Let me go back. Is the same thing as log of 2 times 2 times 2. So basically we have 3 log 2s. All right, so for our power rule, I guess long story short, whatever this exponent is can be brought out front. And this only works for log terms. So therefore, log of x to the y power, we can rewrite it as y log x. And now this last one, we have a few different things to work with. We have log of 4 plus log of x squared. These are all connected through addition because they're all being multiplied, plus log y. And then to go a little further, we can apply that power rule. So we have log 4 plus 2 log x plus log y. And that's what we're going to work on a lot next class, is expanding and condensing these different log terms using these rules. So you can flip on to the next page. I'm not going to sit here and let the video run, but I would pause. This is exactly what we just defined. So please pause the video, get these terms written in your notes, and I'm going to move on. So pause now so you can get these in. All right. So let's see. One thing, I guess, before we get, well, you know what? We'll come back to this next time. I think we'll talk about this next class. So you can just jot that down. I don't think I have that written in your notes anywhere. But real basic, just looking at some constants here. So no variables. We're going to practice expanding and condensing these log functions. So what I want you to do first is find a different way to write the natural log of 12 in terms of 3s and 4s. So I'll show you what I mean, then I'll let you think about the second one for a minute on your own. So we know the natural log of 12. If I want to write this in terms of 3s and 4s, I know 12 can be written as just 3 times 4. So those are equivalent terms. And now if I wanted to break these apart, this could become natural log of 3 plus the natural log of 4. So that's all. Just practice playing around with these a little bit. So I want you guys to take a minute, see if you can write the natural log of 16 in a couple different ways. See if you can rewrite that using 3s and 4s in a couple different ways. And then we'll come back and finish up. All right, so a couple different ways to do this. We know 16 can just be written as 4 times 4, which we can then break out through addition. Since the terms are being multiplied, we can separate them through addition. So we're left with natural log of 4 plus the natural log of 4. Those are like terms. We can combine them, and it becomes 2 natural log 4. But kind of a neat thing to see, we can also write 16 as 4 squared. So we can write this as the natural log of 4 squared. But now using our power rule, we can bring the 2 out front, and it becomes 2 natural log of 4, which gets us to the same place, which is kind of cool. All right, so I think we're going to do one last question together. We're going to have a lot of time to practice this next class. So let's look at, you know what, why don't you try this one here? I want you to pause, try it on your own. There's one kind of important thing I want to mention. And actually, hang on, I got a better idea. Let's do this one. Let's do this one that I mentioned before. So please pause, get this jotted down, and then we'll go through my thought process after you're done. So pause, do it now. When you are ready for me to speak about it, you can unpause. All right, so here's why I wanted to talk about this one. We'll get into these next class. If you want to mess around and try a couple of these out, you can. But we're going to have a lot of time to practice these next time. The reason why I wanted to talk about this one, it's all about the signs. It doesn't matter where they are, right? So if I wrote 2 minus x to you guys, that would be the same thing as writing negative x plus 2. The x is still negative no matter where it is. So for here, I know these are all same bases. So log base 3 is going to be what I can pull out, and I'll have that as my overall kind of expression. It's log base 3 of some stuff. So the x here is a negative. So that negative means it's going to go in the denominator of my function, of my expression. Okay, so that's basically the quotient rule. Anything with a negative sign is going to go in the bottom of my power, the bottom of my expression, bottom of my fraction. The y has a positive, so the y goes in the numerator. All right, now the z has another negative term with it. We're not going to start making more fractions, right? We're not going to make another denominator. That z just goes in the overall denominator of my expression, right? I'm not going to start throwing denominators over denominators over denominators. That z just goes in the denominator with the x. And then the w is positive, so that's going to be addition up in the numerator with my y term. So basically anything that's positive is going to go in the numerator. Anything that's negative is going to go in the denominator. And here's one more really cool way to see this. If I kind of reverse the power rule here, if I bring this negative, if it's like a -1, if I bring that up top here, this becomes log base 3 of x to the -1 power. And we talked a couple of classes ago, anything with a negative power basically goes into the other side of your fraction. So that's another way to think. Anything with a minus in those log functions, those log expressions, are going to end up in the denominator of the term. All right, so there's your homework. Make sure you read what I'm asking you to do on the Google form. I'm not sure yet, but I will come up with something, and I will see you guys next time in class. Bye.